Okay, cool. Well, welcome back, folks, and thanks a lot. So we now have Stephen Fluin from Axelar that's going to be uh, talking about. Well, you can introduce what you were talking about bridges, right? Um, so, yeah,
Over to me.
yeah. Over to
Sounds
you.
good.
If you want to share your screen, it's about the sixth icon along the bottom there.
Yes. Hopefully everyone can
Great.
see what I'm presenting now.
Yep, we can do. Brilliant.
All right, and I think I have the Twitch chat up here as well. So feel free to ask questions as I'm going, and I'll try to answer as many as I can. I assume we're stuck to a strict half an hour. Is that correct?
Well, you are the last talk of this session, so if you want to run a little bit over, then that's fine. So
Uh,
if you want to go a little over half an hour, then that's not a problem.
Well, I'll probably take the time we've got, and then we'll dive into Q&A if we have any questions. But hello, everyone. My name is Stephen Fluin. I'm the head of developer relations over at Axelar. You can follow me on Twitch, Mastodon, theoretically Blue Sky at some point. If anyone has an invite, I would love to get one of those. But I really like to start these sort of presentations understanding a little bit about why Axelar exists. And to understand that, you really have to understand that there's been a shift going on over the past few years. If you were a developer coming into web developer into Web3 development or crypto, like let's say 4 or 5 years ago, things were simple. Things were easy. You basically had you with Ethereum, you learn Solidity, and you deploy smart contracts there. And so there was very few choices, but rightly so. More and more chains have been coming out because every chain is able to take a different approach on this kind of world that we live in. Whether that is chains that are more privacy focused, chains that are more scalability focused, chains that have like the storage network that Filecoin has. All these different chains bring their own value proposition to the story of Web3, but we've kind of also entered this world where we're seeing more and more app chains. And so for you as a developer, now you have to be, it's much harder to enter the space because of this paradox of choice, where now you have to figure out, how do I connect to all these different blockchains? How do I figure out what to do for all these different users? And Axelar basically wants to come in and make that story a little bit simpler. We want to make that easier for developers. And the vision is that at some point you might not even have to think about this as a user, like what chain you're on, what capabilities you're accessing. So what if you didn't care what chain you're on? What if you were able to take advantage of these differences between blockchains, right? Like the FVM is so powerful in terms of being able to manage and connect to this storage network programmatically from other blockchains. And then what if you could be where your users are, right? So obviously the FEVM is relatively new, so there's not as many assets there. There's not as many dApps there. What if you could actually take advantage of dApps that exist on other chains and connect them into the things that you're doing on FEVM? Like that to me is what's really, really exciting. And that's what Axelar is trying to make possible. Axelar is connected to, I think, like 38 different blockchains right now. So we ourselves are are built on a tech stack based on the Cosmos SDK. So we're in the Cosmos ecosystem, but we're really trying to be this interoperability layer. And there's two main things that we actually do. Actually, I'll come back to that. So if you think about Axelar, when because there's a bunch of different options and a bunch of different ways you can send messages across blockchains, send tokens, those sorts of things. For us, we're really focused on security and decentralization. So we spent a long time in testnet before we went to mainnet last year. So trying to get things right so that we don't, because we all hear about these bridge hacks and all these problems. And the other thing is really focusing on how we can do all this interchain messaging in a decentralized way with the decentralized validators and a trust minimized system. I mentioned we're going to integrate into 38 chains as of today. And we really focus on developer experience. So making it easy to send messages, send tokens, all those sorts of things. And I'll be walking through some of that today. So when I think about Axelar and the feature set that we actually offer, I separate things into two universes. On one side of the world, we've got the ability to bridge and send tokens. So we've got deposit addresses or something. We've got an on-chain method called send tokens. And we actually have this new capability called interchain tokens, which I'll show in a moment here. But the first one I want to talk about is deposit addresses. Deposit addresses are basically the idea that we're going to bake together the source chain, the destination chain that you want to send assets to, the destination address, and an asset. And then what happens is you create one of these deposit addresses and it gives you that deposit address. And then from then on, any tokens that you send to that deposit address automatically get bridged to that destination address. And one of the nice things here is that you don't actually even you don't even need a wallet on that chain, because you can use that deposit address kind of as a wallet or a transparent layer. So one of the examples of this that you could think about is, hey, what if I want to pull money out of a DEX or even a centralized exchange on Polygon, on Ethereum, et cetera, and I want those assets to end up on Filecoin or the FEVM. You can do that with a deposit address. You just create a deposit address on Ethereum. You don't need to have any assets there. You don't have any wallet there. And then that deposit address can be created that will automatically forward all those assets to Filecoin. So we think that's a really exciting, really easy way for developers and users to move assets around. And we do have an on-chain equivalent called SendToken. So we've got an EVM gateway, gateway contract, smart contract that exists on all of the EVM chains that we're on. And you can just basically call the SendToken method on any of those gateways. You can pass it what destination chain you want to send, what the destination address is, what asset, and then the amount. And obviously, you have to approve that. You have to approve the gateway on the token, but it's relatively simple, just to like 1 or 2 transactions, and you are able to go ahead and transfer assets into the Filecoin universe from anywhere else in the world. The last one, so the first 2 methods that I mentioned, so this deposit address and that send token, it only supports tokens that are kind of natively supported by the Axelar network. But we know that there are many, many more tokens that we don't support natively. So what we built is what we call our interchain token standard. And so this is a web interface as well as a bunch of smart contracts that basically enable you to take any ERC20 on any of the EVM blockchains that we support and create a version of that token on all the blockchains. And then we give you you're effectively creating your own bridge, because you're given all of the methods on your contracts that enable you to send tokens back and forth, where we automatically handle the locking, the releasing, the minting, the burning, to really give you this single token that works across a bunch of different blockchains. So that's the sending token side of the world, which I think is a fundamentally important primitive. But to me, it's not actually the most exciting primitive. To me, the exciting thing comes with generalized message passing, or GMP, where we can actually now move, compute, and send messages and interact between blockchains in any arbitrary way that we want to as developers. So you can think of this as, instead of moving assets to the compute, you can think of it as moving the compute to where the assets are. So imagine your home base is the FVM, and now you want to send a message and do something on another chain or interact with someone else's smart contracts. You can do that now with general message passing. These methods should actually look relatively similar to the ones you saw with send token and get deposit address. Effectively, in Solidity, you can specify the destination chain, the destination address, and the payload that you want to send, and that can be anything you want to send. It's basically just a bytes. And then on the destination chain, you have the corresponding one where you're given the source chain that the message came from, the source address that it came from, and a payload. And you'll notice this is actually an internal method, because what happens within the Axelar network is we notice that a message was initiated on a source chain. A set of independent validators achieve consensus and say, yes, this happened, this is truth. And then they sign a message that gets approved on the destination chain. And then that approval then allows execution on the destination chain, which then calls your internal method. So you can be sure that any function calls that get into your execute method have been verified, have been attested to by a decentralized set of independent validators. One of the hardest parts when you start thinking interchain, when you start building these more complex applications, is how do you pay for all the gas? Because you've got gas costs on the source chain, you've got the Axelar gas cost for that decentralized consensus around what is truth, and then you have the gas costs in the destination chain where you're actually executing whatever code that you've written. We've built a method that tries to make this very, very easy, where we have this pay native gas for contract call method. So effectively what you can do is you can pay on the source chain for that end-to-end message. So you pay in the native currency of the source chain, and that will pay for the decentralized consensus, and that pays for the execution on the destination chain. So really making it easy, so you don't have to worry about relaying, you don't have to worry about going and putting gas in all the different chains that you want to interact with. When you think about general message passing behind the hood, you've got your source chain where you've got your app logic, you pay the gas service for the end-to-end transaction, then the gateway picks that up. It's approved by the Axelar network, or confirmed that it happened by the Axelar network. And then that confirmation approval is passed to the gateway on the destination chain. And then we call out to your dApp logic. So you can actually see those end results and do something interesting with them. So the best way that I find to actually show people and get people started with sending messages and building these kind of arbitrary interchained apps is actually to live code it. So I'm going to go ahead and do that. So we're going to jump over into Remix, where basically I've got a blank file here called gmp.sol. And what I want to do with you is I want to build a relatively simple smart contract. We'll deploy it to Filecoin. We'll deploy it to, I don't know, Binance. And then we'll send a message from one chain to another, and we'll see how we can actually execute across chain. So let's go ahead and start off by just setting up a really simple smart contract. And I'll just close these things out, keep the focus here. Okay, so simple contract. So we'll just say pragma solidity 080. Typing is hard in front of other people. I apologize. And this is going to be a contract called sender receiver. So you could theoretically separate and have a sender contract and a receiver contract that do different things and have different addresses and things like that. Or we can build it all into one contract so you can kind of create this peer-to-peer network of smart contracts. So that is it. We now have a smart contract, but now let's go ahead and actually do something interesting with it. So I'm going to pull in a few different imports. And so I'm going to import a few different things. So we'll just get this set up here. So we're going to import from, and all this is going to come from the Axelar network NPM scope, Axelar GMP SDK Solidity, and then contracts. Now, the three things that we're going to actually want to pull in are going to be the Axelar executable. This is a contract that we're going to extend and inherit from that gives us those methods like execute, where it's actually verifying that the message is valid before it passes it to that internal version. So that's going to be from the executable folder and Axelar executable.sol. By the way, if I make a mistake during this demo, it is definitely going to be in these imports. So feel free to call out if you see me make any mistakes. The second thing is we're going
Live
to want to
coding's
interact.
always a good one, isn't it? Right? Live coding.
Oh yeah,
It's
it's
yeah, but it's the best way. So I'm glad you're doing this. I love this. This is why I love getting people on and doing live coding, because you get to see and the best thing being is people get to see that we're not superhuman, right? We make mistakes too. We make typos. We have to Google stuff, right? So it's always great. I like that's why I love people doing live coding. So crack on. This is
it's
good.
real. Like you see real live debugging, you see real live typos. It's amazing.
Yeah.
And if I can do it in 20 minutes, you can follow along and type the same things and get the same results. But hopefully
Yeah.
you're building something that matters to you, which is what matters. So we need a handle on the iAxelar gateway. So this is the interface for the Axelar gateway so that we can get access to that send token and call contract methods, etc. And then the last thing we're going to need is that gas service. So that's going to be iAxelar gas service. Gas service. And we're going to pull that one in from interfaces. Oops. I don't know why Chrome is prompting me for a password. Interfaces iAxelar gas service. All right, we have our three interfaces. Let's start putting them to use. Pragma solidity. Have I already made a typo? I think Remix has just fallen behind. So we're going to keep going here. So the first thing we want to do is let's actually create a constructor. And that constructor is going to take two things, because the two things that are going to be different on every blockchain that we deploy to are going to be the gateway. So we'll take in the address of the gateway, and we're going to take in the address of the gas service. And so what we're going to do with those is the gas service, we're going to store that. So we're going to create an iAxelar gas service. We'll just make this public immutable. We'll call it gas service. And then in our constructor here, we will just save it. So we will say that gas service is a new iAxelar gas service at the address that we have here. And the other piece that we need to save is actually the gateway. And the way that we're going to do that is we're going to extend the Axelar executable. So we're going to say sender receiver is Axelar executable. And then I will add it to the constructor here, Axelar executable, and I will pass in that gateway address. All right, so now when we deploy the smart contract to any blockchain, we're able to configure the gateway so that it knows how to communicate to the gateway, which will send the messages cross-chain, and it knows how to pay for those transactions. So let's go ahead and now start using some of these capabilities. So the first thing I'm going to create is the ability to send a message. So I'll make a function called send message, and we're going to take a few different parameters. So I'm going to take a string call data of the destination chain, string call data of the destination address, and we're going to create a string call data of our message. So with those three parameters, we know where a message is going to go and what the message actually is. So let's go ahead and implement this. It's going to be external and payable. So it's payable because we want anyone to be able to send a message. And in order to do that, they need to pay the native gas in order to execute that cross-chain transaction. So for sync, let's go ahead and encode our message. So we'll say bytes memory payload is equal to the ABI encode of our message. Now we have our actual message that we're going to be sending. Let's go ahead and pay for the gas. So I'm going to call the gas service, and it's got a method called pay native gas for contract call. It's a very long method name, but it's very specific, and it's hopefully clear what it's doing here. And we're just going to pass all of the ETH or FIL or AVAX or whatever we pass in. We'll pass that directly to that gas service. And then we'll give it the parameters. So we're going to tell it what this contract is. We're going to tell it where the message is going. We're going to tell it the address that it's going to. We'll show it the payload because the payload is going to drive some of the cost. And we'll tell them who is the original sender of this message. So with that, we have now paid for our transaction. And now we can actually call the gateway and send it, and something magical will happen. So we'll say gateway.callContract. And I'm going to pass in the destination chain, destination address, and the payload. This should look pretty familiar by now. So we are now able to send messages, but in order to actually receive messages, we need to implement the corresponding execute method. So it's going to look very, very similar at this point. So we'll just create an execute method here. This is going to take a string call data of the source chain. So when the call comes in from Axelar Network, when it gets executed, we tell you where the message came from that decentralized truth. We've got string call data of the source address and, bytes call data of our payload. With those three things, now we're going to make this an internal override because we're implementing the interface from Axelar executable. And then let's just save out that message. So we'll say message equals abi.encode, our payload, and we're going to tell it that it is a string because we created this message. So we need to actually save this here. So let's just say that this is going to be a string public message. So it's very, very easy to read. And with that, we missed a comma, payload comma. ABI encode payload underscore bytes call data. I think Remix is just behind again. String storage ref. All right, well, we're going to give this a try and see if we can compile. Sometimes that will get rid of the errors. Type cannot be encoded. So we've got, let's just walk through here. So we've got a bytes call data called payload. And we're I'm encoding it again. Need to decode that. Perfect. Of course, you can't re-encode with you don't need to specify the type when you're encoding. So this is going to be a decode of the payload as a string. And we've got a couple errors here because we're not using the source chain source address, but warnings, but we can just ignore those. So let's go ahead and now deploy these out to Filecoin. So let's make sure that it's compiled. And now we're going to go ahead and hit deploy and run. So in MetaMask here, I should see Filecoin Hyperspace. Perfect. And now I'm going to give it the address of the gateway and the gas service. So this is really easy to find if you just go in the Axelar docs and you scroll down to resources, testnet, or mainnet, or whatever environment you're in, you're going to see the address of the gateway and the gas service on every blockchain that we support. So we'll just paste it in here. And we will hit transact. So that should create the contract. All right, and I have noticed that the FEVM sometimes takes a little while to create contracts. There's a couple ways that we can watch this. Is we can go to either the mempool and see our contract creation. So here it is sitting there pending. And then as soon as that completes, we should be able to get that contract address. But one of the things I want to do is while we wait, I don't want to wait for that. So I'm going to go ahead and create deploy the same contract over to Binance. And then we'll send messages back and forth between those two blockchains. So let's switch over to BNB chain. Perfect. All right, now what we're going to do is we're just going to do the exact same thing and copy the BNB chain gateway and gas service, and we'll deploy it there as well. Gateway, gas service, and we'll deploy it to that blockchain. Hopefully I haven't messed anything up by switching MetaMask in the middle here just for speed. So we should see contract or create external as soon as that FEVM transaction gets mined into a block. So I think it's probably still sitting in the mempool. Yep, there it is, still sitting in the mempool. Oh no, it's gone. So we should see it in my. Yep, there we go. Okay, so we have the contract address. So what we can do now is if we take a look at that contract, we should actually get the address of our contract. So let's just write these down so we have them. So we've got there, that is our Filecoin address. This is the address of our contract on Filecoin. We should just be able to verify that real quick in the Hyperspace Explorer here. This is the contract address. Perfect. And now what we should be able to do is write down the same thing for the Binance chain or the BNB chain. So the second one that we've created here, yep, I think it's that one. The string for BNB chain is actually the word Binance, just so we're all on the same page. That's what that is. And now what we should be able to do is actually interact with this contract on BNB chain, and we will send a message. So I will send a message to Filecoin and the destination address that we just created, and I will send the message, hello world. And the last thing we need to do is we need to actually pay some FIL with this, or actually we're originating the message on BNB. So this is BNB. So let's just send, I don't know, 3. What happens is if you can overpay very easily, and everything that doesn't get spent just automatically gets refunded to you. So don't worry about over sending on a transaction. So let's go ahead and transact that on BNB chain. All right, that block has been mined. So now we should be able to take this transaction hash and jump over to one of my favorite tools when interacting with Axelar, which is the Axelar scan. So here you can basically see everything about the network, everything from the chains that are integrated to all the transactions that are going through, stats, all those sorts of things. And you can paste in a transaction address from any of the chains that we support. So you can see, and it'll actually pop up. And my favorite thing about this is not an individual transaction on an individual blockchain. This is kind of the aggregate of what's happening across all of these blockchains. This is the context of a message. So you can see we originated a message on BNB chain at this source address, and we're sending that message all the way over to Filecoin at this address. And what's happening behind the scenes is we can see that the contract call happened on the source chain. The gas was paid on the source chain. Right now, we are doing confirmation. So effectively what the independent validators are doing is they're waiting for finality on the source chain. So they're waiting for BNB chain finality so that we can trust that the block that was mined is actually going to be in the chain. And then as soon as that happens, the relayers will go ahead and approve. They'll pass all the signatures from all those independent validators to the destination chain so it can be verified and approved. And then that contract call will get executed. And so we should be able to see as soon as this completes end to end that our message is passed. And so I'm going to just switch back to Filecoin here and see if we can see our contract that we created. So we should just be able to, in Remix, say it's at this address and just check it. We'll just ask for if it has a message. Yep, it's got an empty string right now, which is exactly what we expect. When we deployed this contract, it had no message. So as soon as this full end-to-end interchain transaction completes, we will see that this message will get updated. So we'll come back to that in a minute. So I'll just finish up the slides here. So we've built this smart contract, this gmp.sol, that's able to send messages, receive messages, and that is kind of where your creativity now takes over. So we've seen all about sending tokens, we've seen about sending messages. One of the ways, so you can obviously, you've seen this video, there's videos of this available online. You could follow along exactly what I did. But one of the things that we offer is this Axelar examples repository. And so this repository is fantastic because it basically, what we've done is we've given you code samples that are just ready to go for a bunch of the common use cases. So you can send a message, you can like call contract across, and you get both the Solidity code, just similar to what we just wrote, but you also get the hard hat code, for example, if you want to deploy that and manage it in a centralized way and test it and all those good things. So we've got that for calling contract, sending tokens while you're sending a contract, cross-chain lending, NFT linking. If you want to bring a bunch of NFTs and link them into Filecoin, I think that'd be very cool. You can send and acknowledge messages. You can actually have like a message that goes out and a response that comes back. All these sorts of things are just baked into these examples that you can just basically run. So just check out the Axelar examples repo. And then we've got some fantastic readmes here for basically every example where it says, hey, deploy it to the local version or to a testnet and then run execute. We also have other tutorials. So I skipped over a lot of the asset sending part of this, but if you're curious about interchain tokens, sending tokens, check out the Axelar YouTube channel. We've got kind of hands-on coding of all of those as well. And then what's next? So we've got this fantastic hackathon going on right now. We will be monitoring the Filecoin hackathon channels, but then in general, if you ever want support with Axelar, you can definitely come over to our Discord in the developers channel that we've got going. And we really can't wait to see what you build. So before we finish up here, let's jump back to Remix, which apparently has died. Let's see. Hopefully it didn't lose my contract addresses. Let's open gmp.sol here. Okay, thankfully we have not lost our contract addresses, so we should be able to double check and see if our message, it was approved on Filecoin, so you can see the Filecoin transaction right now. So the last step in this process is that execution. And so as soon as that execution is complete, that's when the relayer actually calls that execute method. We should see that our message here on the Filecoin EVM is correct. I think that is a RPC error because we weren't seeing that before, unless I pasted an address wrong. But yeah, so I'm not going to wait for this. Let's just finish up. Oh, no, it is executed. So we can actually see the Filecoin transaction here, which should have transacted out to my contract. Just to triple verify the address. Yep, that looks right. A RPC error if we can't see the message. Yep, where we're not seeing the message. I'm not going to be able to debug this right now, unfortunately, but if you go and take a look at this address on your machine with a working RPC endpoint, you should be successful. All right. With that, we can't wait to see what you build. And that is going to be it for this presentation. I'm happy to answer any questions you have or have any discussions you want to have.
That was an awesome demo. I love that. That's really great. I want to get stuck in with that myself. That's yeah, just to show kind of how easy that was to do that. Because one of the big things is like Filecoin is obviously very specifically tailored to storage, but now to basically be able to offer that storage capability to the whole rest of the Web3 world and whatever blockchain you're on, using technology like Axelar makes that a lot easier. So that's
One
really
of the
cool.
one of the coolest examples I've come up with is like control access permissions on the FVM when a NFT transfers. So like you've got an NFT on Polygon, you sell it on OpenSea. As part of that transfer, automatically update the Filecoin permissions, which I just like that sort of like ability to combine the best of two blockchains. Just really is
Right.
exciting to me.
Yeah, that's cool. Okay, we have had a few questions in here, I think. For the hackathon, the bounty requires us to use GMP only, asks Magic.
Yeah, so the thing we're most interested in is you using message passing to do something interesting or arbitrary across. And so basically, what you should be able to see in Axelar scan once you've done a transaction is this method with call contract or call contract with token, where you have a contract call from a source chain to a destination chain. There's a bunch of ways of doing this. So you do that with Axelar scan. Theoretically, if you integrate the Squid SDK. They use GMP under the hood as well. So like by using the Squid SDK, you're also using general message passing, as well as if you do something with, for example, interchain tokens, that uses general message passing under the hood as well. So like you could build your own, I don't know, interchain NFT tool, deploy that to a bunch of blockchains, and then send messages that kind of mint and lock and burn and release NFTs with Filecoin. So that would be an example of using GMP to across all these different blockchains.
Yeah, that's cool. And I like the way you handle the gas management as well. That's really nice to be able to do that. I've played around with sort of like bridging, not in sort of message passing type terms, but just in general terms. And like you move token from the other bridge, and you got to do something like I haven't got any native gas now, so I can't do something on that network, and you end up with a bootstrapping problem. You've got to get native gas on there, and yada yada yada. So having that that gas service that can do that for you from natively from the source chain you're on, and you don't have to deal with any of that on the destination chain. Again, that just makes that really easy for
And
developers to be able
and
to
I've
call
seen
out the
so
foreign
many.
chain.
Yeah, and I've seen so many people be really excited about this, even the concept of two-way contract calls, where you can send a message, let's say, imagine from BNB to Filecoin, and then within that execute method, you can call back the source and send a message back, and
Oh,
it will continue using that original gas payment. So you don't need any
oh
funds on the target
wow.
destination chain.
Okay, that is nice. And then there's just a question about tokens. Magic has asked, what's the best way to convert the Axel USDC tokens to native USDC tokens? So I know this is not a GMP question, but I
No,
guess
no,
while
no.
you're
It's
here,
it's it's totally valid. So normally the answer is decentralized exchanges. So
yeah.
on most chains, there is a decentralized exchange where there's a pair between Axel USDC and USDC, and then you can use that to convert. We have been working with the Circle team a bunch. So I think in docs.axelar.dev, we actually now have an example where you can use, instead of our token bridging, if you just want to like live in the USDC world, Circle just released CCTP. And so this is actually a code sample where you are using CCTP for the token sending, and then you're doing something interesting with that with GMP. So this code example, uh, you can see this is a cross chain swap using Circle CCTP for bridging rather than using Axelar's version of USDC. And so you're still using general message passing because you have to send the message to the destination chain of like, what token do I want to swap back to? What exchange am I going to be using? All those sorts of things. But you're just kind of sending it along the two paths. So you're sending the general compute via GMP and you're sending the token via CCTP. So yeah, perfectly valid use case.
That's great.
Well, I don't know if CCTP, or I don't know if native USDC is on Filecoin yet.
That's exactly. Magic's just asked. CCTP does not support Filecoin at the moment. No, that's one of the things I think we're working on is getting those like native USDC on there, issued by Circle directly rather than via third
Yeah.
party. So
So, and
yeah,
I mean, that happens on a lot of chains. And what we've seen is that in several cases, like Osmosis on the Cosmos ecosystem, AXL USDC ends up being the canonical USDC because like we just make
right.
it so easy to get there.
Yeah. I've used it on Carver's network, AXL USDC on Carver's network. So
Yeah.
cool.
So like if you want to create a deposit address satellite, that money is the UI where you can basically just say, hey, I want to send some USDC to Filecoin, and then we've already got a canonical version there, effectively.
Awesome. That is cool. Great. Okay. So folks, any further questions here? If there's any more, then put them in the chat very soon because I think we're just wrapping up now. Thank you very much, Stephen, for that. That was a fantastic demo and great to see, Axler technology. And yeah, I'm really interested to see what people build as well. Again, this is a great opportunity to extend the functionality of Filecoin Storage Network and Filecoin Storage Deals out to other networks as well. That's one of the things we're very keen on within Protocol Labs is, kind of exporting the functionality of Filecoin and decentralized storage to other blockchains and allowing them to use that as well. So that's really cool. Great. Well, that brings us up to the end of this series of workshops. So thanks a lot, everybody, for tuning in over the last 3 days for talks. And yeah, let's see what you all build. And so thanks a lot. And once again, thanks a lot, Stephen.
Cheers, everybody. Good luck building.